Alright, welcome back guys. We have section 12-4 today, which is involving angle measures and segment lengths. Today we are focusing on part 1. It's a 2-day lesson, which is only going to discuss the angle measures. Tomorrow I'll be posting on the second part, which is on the segment length specifically. Alright, so let's look at a theorem we have. It says that the measure of an angle formed by two lines that, well, we're going to focus on this first case first, hence, wrong button, hence number 1 here. We're going to focus on this one first. So the measure of an angle formed by two lines that intersect inside a circle, right, intersect inside a circle, is half the sum of the measures of the intercepted arcs. So looking at this picture to our right here, we have, it's illustrating this. First of all, we have two lines that intersect inside the circle, right? So these two blue lines intersect inside the circle. If I want to find the measure of angle 1, okay, the measure of angle 1 here. Notice, first of all, these are vertical angles, so it's either one of those that could be called angle 1. If I want to find the measure of angle 1, I would take arc X, right? I would add, let me choose a different color here so that you can visualize this. I would take arc X, the measure of arc X, plus arc Y, the measure of arc Y, add those together, and then cut it in half. Or in other words, I'm finding the average, or what's right in between those two arcs. So we're going to look at a proof in a second, but just really quickly, if X is 100 degrees and Y is 80 degrees, then angle 1 would be half of 100 plus 80, or half of 180, which is 90, which is right again. One of them's 80, one of them's 100. What's right in between those things? Well, 90 is right in between those things, right? 10, 10, 10. So that's another way of looking at it. It would be 90. But we'll look at more examples in a second. Let's prove it first, and then we'll jump down to part 2. So let's prove it. I'm not going to prove part 2. There's an exercise in your book if you'd like to do that, but it's a similar strategy to what we're going to do in part 1. It's really not that hard of a proof. So let's look at this. So the proof, again, all that we're given is that AC and BD intersect inside the circle. Inside the circle. Oh, I don't know why I did that. Okay, that's all we know. And we want to prove that, and we'll call it here, this is angle 1. We'll call this X degrees, Y degrees. We want to prove that the measure of angle 1 is half X plus Y. Okay, well, what you're going to do first, and this is kind of one of those steps that you don't necessarily see right away, you're going to connect A to D. You're going to make segment AD, right? Because again, we know how to, or we at least we've had experience working with triangles before. So by creating triangles, we can start doing some things with the angles. And what also is nice about this is it creates two inscribed angles. So that's one inscribed angle there, and that's another inscribed angle there. And those inscribed angles specifically relate to arc X or arc AB, right? This arc here, and arc CD or arc Y, which is that arc there. So how do those relate? Well, we know that the measure of angle BDA, which I'll highlight for you here, BDA, so this angle down there, we know that angle is half of X, right? Or half, half of X, because again, the arc that it creates is X degrees, right? Well, we do the same thing with angle CAD, so the measure of angle CAD is half of the arc that it creates. So first of all, angle CAD is here, right? So it's this angle I'm discussing there. It's half of the arc that it forms, which is arc Y, so it's half of Y. And the reason for that would just be the inscribed inscribed angles theorem. Right? Well, how does angle 1 relate to all this? Well, if we're looking at angle 1, we should remember now that in this triangle that the three angles here all add up to 180, right? We can call this, lowercase a, lowercase b, lowercase c. So a, b, and c add up to 180. Well, you don't have to go through this whole process, but if you remember from before, there's something called the exterior angles theorem. The exterior angles theorem says that angle 1, or the measure of angle 1, again, this is angle 1 here, is congruent to the two angles that it's not touching, the sum of them. So we know that the measure of angle 1 equals the measure of angle BDA plus the measure of angle CAD. We know that's true by the exterior angles theorem. So how do we know this? A little arrow here. The exterior angles theorem. Well, now we're just going to use substitution, right? We can just substitute these in. So we know that BDA is the same thing as half of x, and we know that CAD is the same thing as half of y. So we can just substitute that and say measure of angle 1 is just half x plus half y, and we're so close to what we're trying to prove here, just factor out the 1/2, right? So this was by substitution, and then you end up with measure of angle 1 equals 1/2 x plus y. And you're done. So again, we're going to look at part 2 in a second, but proving that is a similar strategy. So let's look at part 2. We have, again, the measure of an angle. Let me erase everything up top so it doesn't get in the way and confuse you. Don't want to confuse you. That would be bad. So, the measure of an angle formed by two lines that intersect outside the circle this time, so that's one thing that's different, is not half the sum but half the difference of the measures of the intercepted arcs. So now we have two lines. These are three different cases, two lines that intersect outside of a circle, right? All of those three cases are your three specific cases. These two lines are called secant lines, and they're called secant lines because they go through the circle, right? They go through the circle, they intersect it twice. This one is one tangent, one secant, and this one is two tangents. So we have two secants, one tangent, one secant, and two tangents. So those, I mean, that's just a little vocabulary for you, but those are all circumstances where the same thing is happening. The lines are intersecting outside of the circle, right? Outside of the circle here. So how does that help us? Well, the theorem says now that the measure of angle 1 in all three of these cases, I'm going to look at the two secants for now, I'm going to look at this case specifically, but the measure of angle 1 is just half the difference. You do big arc minus small arc. Big arc minus small arc. I also end up with a negative, which wouldn't make sense. So the measure of angle 1 is half of x minus y. So remember, it's big arc minus small arc. Measure of angle 1 is half of x minus y. Again, I'll leave the proof for you later, but let's look at some examples here. Okay? So that was our proof before. So in both of these cases, you should first notice that they're intersecting inside the circle, right? These 2 points where they intersect are inside the circle, which means you should think automatically sum. We're looking at the sum. We're adding, we're not subtracting. So inside, we are adding. Another way to think of that is this makes kind of a plus symbol. It crosses inside the circle, right? Where the other type, if you have them intersecting outside of the circle, you see a minus sign, basically, inside. They don't cross in the circle, so it's subtracting. Okay, so that's just a random way to remember. You don't have to use that if you don't like it. But in this example 1 here, if we're trying to solve for angle x, well, this is just direct use of the proof, right? It says that x is half of the sum of the intercepting arcs. So this arc here and this arc here, because those are the ones that intercepts. So we just do half of 100 plus 150, which gives us half of 150, which means it's 75 degrees. Right, so pretty straightforward there. Now y is just a linear pair, so you just do 180 minus 75 to get y equals 105. Right, so you don't have to do anything with the arcs necessarily. The reason I put this in here is because sometimes it's using old skills. You don't have to always use the arcs. So that's, again, that's just direct use of the theorem that we just learned. Now, this next one's not so direct. They give us the angle inside the circle, right? And we're trying to solve for one of the arc lengths. So again, we're saying that 150, that's the angle itself, is half of the sum of the intercepting arcs. We know it's going to be the sum. Well, one of the arcs is 160, one of the arcs is x. So now we're just kind of solving indirectly. Some people like to distribute here. I like to just get rid of the half by multiplying both sides by 2, right? Because that will make those cancel. So multiply both sides by 2. You get 300 equals 160 plus x. Subtract 160, and you get x equals 140 degrees. Okay, so those are the answers for you there. Okay, so I mean, again, this proof's pretty straightforward. It's not too complicated, but it can throw some curveballs at you. All right, I'm gonna there's a few more examples I want to run over with you, and I don't have time to fit it all into one part, so I'm gonna skip on to the next part. You can watch part 2 of this, which is just going over the rest of the angle measure examples. Okay, so watch part 2. See you there.